So I'm going to working through the problems here 1 through 4. You can change these to x's. Some students prefer these to be x's or b's, however you want to write them. All right, so 1 times 21 is a positive 21. Negative 10 is my b value. Remember, this is the AC by grouping method. I want to come up with a combination that multiplies equal positive 21, combines to give us negative 10. So negative 3 and negative 7. So x squared plus 21. Now in the middle, it doesn't matter which order I write these. Negative 3x and minus 7x. These first two, the only thing I'm able to factor out other than a 1 is an x. And I end up with x minus 3. Now I got to make sure I get this right. 1 times 1 is 1 and x squared. 1 times negative 3 is negative 3 and an x. This quantity I'm going to write it back with a light question mark in front. What times x gives us negative 7x? Negative 7. Now, is this the correct value? Negative 7 times negative 3 is a positive 21. Okay, front and back half, they both have the quantity x minus 3. In front of the first is 1x, in front of the back is a minus 7. Again, I switch it to x's based on the preference of the class that is in front of me, but you could also done these. Let's look at the next one, number 2. 1 times negative 7 is negative 7. And positive 6 is what we get for combined. Let's find the combination. So multiplies to give us negative 7, combines to give us a positive 6. So they're different signs. Larger number is going to be positive. Okay, so n squared minus 7. We have a plus 7n and a minus 1n. What can I factor out of the first two? An n plus 7. I'm going to take this group, write it in back. And what times n gives us a negative 1n? Negative 1. Negative 1n, negative 7. Okay, that works out. Okay, they both have an n plus 7. I write it down once. In front of the first is a 1n. In front of the back is a minus 1. Let's look right now at number 3 and number 4. I want to demonstrate in number 3, how can you get the right answer if you don't choose to divide anything? So I'm going to do that right now in this video. And so I'm going to start by, and it's going to take me a little more space. And it's probably going to be pretty complex, so hold with me here. I, first of all, by the way, would factor out 2. That's what I would do. So this is how I would set it up if I was doing it. 7n squared. If I take 132 and I divide it by 2, I end up with 66. 66n plus 27. So this is what I would do, but what if we didn't do that? Can we still get the same answer? Let's check. It's going to take me a little while here. So I'm going to take 14 times 132. Oh my goodness, this is I don't even think I want to do this, but 14 times 14 times 154. I'm already getting frazzled here. 14 times 54, and I have a positive 756. So both are going to be positive numbers or both negative numbers. And then they have to combine to give 132. So because they're combining to give us a positive number and the product is positive, I know both of these will be positive. So I need numbers that are going to add up to 132. So I'm going to start with a combination here, and I'm just going to work myself forward. So like I know 132 add up to 132. When I multiply it, I'm way too high. So let's bump back here. Let's bump back some. So if I take 132 and subtract 50, okay, I know 50 and 82 combine to give 132. So if I take 50 times 32, I get, way too high. So I need to bump back more. 132, and let's subtract 20. So let's try 20, taking 20 times 112. 20 times 112, still way too high. Let's bump down to 10. So if I take 132 and subtract 10, let's take 10 times 122. Okay, I'm getting closer, but I'm still too high. Okay, let's take 5 away from this. Let's take 5 away from this and see where I'm at now. So I'm going to take 5 times 127. Okay, now I'm too low. Okay, so I did a combination of 10 and 122, and the product I had was too high. Then I tried 5 and 127, and the product was too low. So it's somewhere in between here. So I need to do the combination of somewhere in between. So I'm going to try 6, 7, 8, and 9 until I find a combination that works with this. Okay, so let's try 6 now. So I'm going to try 6. And again, all you're doing here, if you're wondering how many of these combinations, is I'm subtracting 6. I'm trying 6 and 126. Okay, 6 times 126. Hey, that's it, 6 and 126. Okay, so positive 6, positive 126. And the only reason why I think it's easier to factor out a 2 right away is that when we're working with this x, we're working with much smaller numbers. So I have 14n squared plus 54. In the middle, I have a positive 6n and a positive 126n. Okay, what's the most that I can factor out of this? I can factor out, let's see, just a 2 and an n. I'm left with 7n plus 3, 7n plus 3. Now, do I know a number that I can take times 7 and get 126? Not at the top of my head. So I'm going to take a calculator and go 126 divided by 7. 18, okay. 18 times 7 is positive 126n. And 18 times 3 is, in fact, a positive 54. So this works. Both the front and the back have a 7n plus 3. In the front is a 2n and in the back is an 18. Nothing that I've done is wrong. But when I look at this factor in back, I recognize both of these terms are divisible by 2. So I'm going to factor out a 2. 2 divided by 2 is 1. 18 divided by 2 is 9. This is the correct answer. To me, those numbers are large and intimidating. And for that reason, I would choose to do this a different way. I recognize that each of these terms is even. 14, 132, and 54. So I'm going to factor out a 2. And then this is the trinomial that I'm going to work with. So I'm going to go 7 times 27. Still a larger number than I like to work with. 7 times 27 is positive 189 and 66. This tells me they're the same sign, so both positive, both negative, and when they combine, they have a positive. So I know both of these numbers are positive. And I'm going to do this in the same way that I did the other. Like, for instance, I know 60 and 6. 60 and 6, they combine to give us 66. Let's see what they multiply to. Way too large, way too large. So let's bump it back here. Let's bump it back and see what else I could do. So I tried 60 and 6, and that's way too high of a combination. Again, the difference here when you combine these, not the difference, excuse me, when you combine these, you have to end up with 66. And this was too large, so let's go back. Let's go 5. So let's try 61 and 5. So 61 and 5 still add up to 66. Let's try 61 times 5 is 305. Still too high. I'm looking for 189. 189. Okay, so let's try 4 and 62. 4 times 62. Okay, I'm getting closer, but still too high. Let's try 3 and 63. 63 times 3, that's my combination. That's what I'm trying to hit. So I have 63 and 3. Leaving the 2 out front, I have 7n squared plus 27. And what goes in the middle is a positive 63n and a positive 3n. Okay, I'm underlining these first two numbers here, and I'm using the factoring by group method. So I'm able to factor out a 7 and an n. 7 times 1 is 7, I need 2 n's. 7 times 9 is 63, and I need an n. Ooh, it's getting kind of messy here. I'm going to write 1n plus 9, and I want to know what number times 1 gives me a positive 3n. Positive 3. When I distribute, I get a positive 3. And positive 3 times positive 9 is a positive 27. So they both contain a 1n plus 9. It's not necessary for you to put a 1 in front if you don't want to. And then in front of the first is a 7n, in front of the back is a positive 3. Now, if you stop here, you're so close, but remember, we factored out a 2 to start with. Some students are going to say, but this looks different than this. These are called factors, and it doesn't matter if this first factor is written in back or if it's written in front. Let's move on to number 4. Again, I'm going to start right away by recognizing that all of these are even, and I'm going to divide it 2. 2x squared minus 7x minus 15. What multiplies to equal negative 30 combines to equal negative 7? This is your A and C, and this is your B. So what two numbers? Now, what do you do if you don't have great number sense? You start with this top number, and don't worry about the positive or negative. Divide it by 1. Is 1 and 30 somehow 7? Nope. Is 2 and 15 7? Nope. Is 3 and 10 7? It is. They have to be different signs, one's positive and one's negative, and the larger number must be negative. Let's write this down. Okay, so negative 10x and positive 3x. What can I divide out of 2 and negative 10? A 2 and an x out of these two groups. 2 times 1 is 2, x times x is x squared. 2 times negative 5 is negative 10, and we have the x. I'm going to write the x minus 5 in back. What quantity times x gives us a positive 3x? A positive 3. We can distribute to get a positive 3, and 3 times negative 5 is in fact negative 15. What do I do next? You've done all the hard work. They both contain the quantity x minus 5. In front of the first is a 2x. In front of the back is a positive 3. Don't stop now. We factored out a 2 at the very beginning.